Okay. So, what function would you like to create?
Well, we could do z plus t or something. It's not on there.
Yeah.
I think you'd have to do this.
Yeah, shift 6. How about just z plus t times z plus t?
Z plus t.
Okay.
I guess that's already in.
All right. So oh, that's interesting. What's going on with this function?
So most of the like if the red was the imaginary numbers, which it was last time, they're being plotted towards the right.
Yeah, I don't know if it stays the same every time though, because like if like presumably this is z plus 1 times z plus 1.
Yeah.
So if I put in 3, I'd get 4 times 4, so the red would be actually going to real numbers.
You can see sort of 3 lines coming out from this single point. Let's see. Well, that might be the point where the function is 0.
Yeah.
Probably.
It is. And why
varies.
why do you think it's just moving back and forth here?
Well, it does it change. It doesn't change at all on the imaginary axis, so it would just be moving back and forth on the real axis.
Okay, interesting. All right.
Let's see. So you can, there's just a bunch of different lines.
Yeah, so
dividing up the colors.
This is a function that looks a lot like z squared, but just getting shifted.
Yeah.
That's an interesting one. All right, try one more.
So we could do z to z cubed, so z times. Yep. Then we could do minus t squared.
Minus t squared?
Yes.
Okay.
Well, it's the same sort of style. It's got sort of threefold symmetry.
Mm-hmm.
It's 3. And could be because of the z cubed. And now it is definitely changing on the imaginary axis, because like if you inputted I into the function, it would come out as negative I, so the function can change on the imaginary axis, and t squared changes it as well.
Yeah, let me show you one that might be pretty neat too. Z squared minus t times z.
It's interesting. So actually there are 2 separate groups of where things get plotted.
Yeah.
There's some red here. And there's separate groups of other colors too. They get separated.
And how about a really wild one? How about sine? I don't know if sine of... I'm just going to put sine of z for a second to see if it understands that. Yep, sine of z. How about sine of t times z?
It's shifting. It just flips suddenly. Well.
Yeah, it's
neat.
That's neat, but maybe z plus t could be also interesting. Oh, that's just shifting back and forth along the axis.
Yep.
But you have these functions, trig functions, are also defined for
complex
complex numbers. Yeah, so this is a really neat graph of how to, or a really neat program for understanding graphs of complex functions. Pretty cool,
Yeah.
huh?
Cool.
All right, good job, man.